Welcome, guys, and let's continue over the next part. Plan for today, guys. Multiple topics, or I can say service, we are going to do and complete today, right? There's very small services, but these service has a lot of weightage in the lot of use cases, right? So the services that we are going to deal today and going to discuss and implement today. So one of the very important services is called SQS. This is the one topic and service we are going to discuss. And then we will move to SNS, again one more service. And there's one more new service been launched by sorry launched by Amazon recently, that is called MQ services. It's called message queue services. So these three topics, guys, we are going to discuss today. Anybody who have any idea about some concepts that we use in the application deployment, that is called middleware. So these are the service that is very much useful in the middleware world, right? So what is middleware? Sorry, sorry. We are going to discuss today, right? So what is SQS, what is SNS, and what is message queue? I will explain you the things from very zero, but let me first log into our AWS cloud. Okay, and this service is very important because it is about not about SQS only. Any kind of multi-tier or maybe microservices kind of application you want to implement or you want to deploy. Okay, these concepts and these services, or I can say not about services because the service is more about AWS, but the concept would be very much important, right? So let's start first service called SQS, and that is called simple queue services, and that is the message queue, or I can say is the managed message queue. So what is managed services? You guys know. So where Amazon say they are managing everything for us, right? In terms of security, patching, update, instances, server, hardware, network. So everything they have managed and they have configured for us. We have to directly go there and use it. That is the meaning of managed services. And we have seen a lot of managed services already. So they are managing the storage for us. For example, from S3, they are managing, some network router and switches for us from the VPS. So, so cloud is all about managed services. Mostly I can say about the managed services, right? So SQS is a managed services, but what exactly they are managing? They are managing the MQ part, or I can say the message queue part. so, so before guys you go for this topic, you have to first be comfortable. What is the meaning of message queue and what kind of use case message queue solve for us, right? So let me explain you guys one by one the concept, and then we'll go and implement this part, right? So let me start with this topic called SQS, and one more minute, guys. Just give me, let me also open a document for you. So whatever we are implementing here, I will share the complete steps by steps document to you. Okay, so let's just start, guys, about a message queue. So let me explain you with one scenario, and this scenario, guys, will explain you the actual use case of the concept called message queue, or I can use the one better word would be queue here. So what is the use of the queue that manage the messages for you? Okay, so you can think in this way. For example, you guys might visit one website, maybe one kind of e-commerce website, and where you select some item. Okay, so select some item and put in your cart. So, and normally whatever you put, guys, in your cart, again, this is similar kind of example I have discussed in my last class also of Elastic Cache topic. This was called cash management. So if you go to, for example, one of the website, e-commerce, and whatever you select, it update in, or you store in the cart. Okay, and for this we require some kind of storage, or some kind of permanent storage, but this storage is normally managed by a database that's called key value pair kind of database, or I can say this managed by some kind of caching server. And we have discussed about two server already. One is Redis and one is Memcached. So this function, guys, is stored in one database, that is maybe cache database we store, right? But after you check out whatever you buy, you check out, and you attach your details of your bank, and you purchase the item. After you purchase the item, after you purchase the item, this particular website is running with one program. And this program you have guys have to communicate it. And this program is the one, they take your order. Okay, take your order, and after they take the order, and you provide your bank details, and finally you bill for this product. So this program is the one who do all this processing for you. Is called order processing. They do for you. Okay, so now what I'm talking about over here is, can you hold for a second, guys, please? So yeah, so after you process your bank details, your order confirm, but there's some program behind the scene running who come to know that your process has been done from the bank. Okay, and they receive the amount. And then what this program do, after they see that your amount is successful, your order is done, what they do, they might guys connect to some more computer. Okay, so there might be one more program running in other computer, maybe in other VM, maybe in other issued instance. So this program will communicate with this program and say that somebody from this account, maybe this account has some associated email ID, actually email ID, and that guy has processed this amount. So I want you are one of our mailing program, emailing program, or mailer, or mailing program. Just do one thing. This is the detail. This is the detail of their order, or their invoice, their billing detail. So let's say this is the invoice ID, let's say 1, or maybe product information, let's say 2. Okay. So I want sorry, I want take this information and send a mail to this guy. So technically, in this complete process, if you try to understand here, we have a very different virtual machine on OS running, where this program use is very different. They are here for order processing. We have different virtual machine running with different program, and this program is dedicated only for email. Or maybe we have one more virtual machine, and in this virtual machine we are running some kind of databases services. For example, maybe MySQL. And why we are running these database services? Maybe because this program also want to share the information to this database and say somebody from this account buy some item. They have done this much transaction with us for this product, they have given this much amount. So store somewhere in your tables, store somewhere in your database for the future reference. So in the future, if this guy come to us from here, and they click here all their order, right? And if they click here, so this application finally in the future will connect to your database. Okay, on this database, whatever information you have associated with this account, you will pull and provide to this guy. Okay, so this is a very simple architecture. There will be a lot of component maybe working behind the scene, but I think this is a very simple design or architecture I'm talking about. So my point, guys, over here is, if you try to understand, if you have this one single website or one single app, but behind the scene, behind the scene, a lot of virtual machines, or it's not a virtual machine, a lot of programs and server running behind the scene, and every server has their own use cases. One for email, maybe one program is running for SMS, one program maybe is a databases, order processing, and lots of other inventory management and hundreds of other programs working behind the scene. Okay. Now, what I'm trying to tell you here is, if you guys notice in this particular in this particular example, if you notice over here, as soon as the customer of this e-commerce site orders something and they process the order, right? This program responsibility to update, let's say this is a program number A, this program is number B, and this is a program of server number C. So duty of A program is to update program B and program C, and B and C accordingly they will do their further processing. Okay, so they can update, but challenge here is there might be possibility, because they are the three independent virtual machine or three independent program. There might be possibility, and nobody have a control on it. There might be possibility the time when this customer buy this product, the program has processed this, they will go to bank and debit the amount from there. But that point in time, there might be possibility this program might be off, or maybe shut down, or maybe not is working. They have the downtime going on, maybe, right? Because you guys know we never have 100% uptime. Normally we have 99.9% or maybe a little bit uptime we have for our programs and for our services. Okay, so see, so guys, maybe we are not lucky at that point in time. Our customer has done some big transaction for us, and duty of this program is to do this processing with the bank. But after they done the successful message come up, they have to store this information in their respective database. Okay, but if the database is down there, so my program A is won't able to communicate with program C. It means they won't able to update in the storage in the database that somebody has done this kind of processing. Or maybe after 2 minutes my database might come up, but because your transaction is going on right now and you have done right now, so program will send the data. Okay, and nobody is there to receive this data or to receive this information, right? So so there might be possibility, right? This information and this data, because you are sending here and the system is down, or your destination is down here, system C, so you might lose your information. And guys, obviously it is not great for the customer, but finally customer pay the amount, and according to your database there's no transaction, right? Maybe you're some kind of maybe e-commerce site, maybe some kind of travels and tour website. So they process the flight tickets from you, but they say they don't have any information about you. Okay, maybe because of this kind of failure, maybe, even though we have a lot of other component also there. That's what we are going to discuss in a minute. But but in this architecture, if you have in this destination service, that your A service means source service want to communicate. So A is the source service and C is the destination service, and destination goes down for that point in time, you might lose your data and the information. Okay, and why we have this challenge? Because A is a service or program that is directly communicating with the C. Okay, and because they have directly communicating with C, it's called directly they have connected or they have integrated, and this concept is called, guys, tightly coupled. So they're directly coupled with each other, or maybe we can sometimes use a concept called synchronous. So they have directly synchronous or sync with each other. Because as soon as something happens in this program, they send it and they want the destination service to be up so that they can sync, they send the data, and this whatever the service they do finally they do for you. So I can say this, both the services is properly actually in the real time sync to each other, or maybe we can use the word called tightly coupled. Okay, and because of tightly coupled issue in this big application, right? There's a lot of multiple services working behind the scene, and if mostly all the services tightly coupled, for example, A and B is also tightly coupled here. Same kind of issue maybe come up here, right? Customer has processed something, and they wanted to send the mail. They contact to B. This B is down that point in time, right? And they're down. So for you, you process the item, right? But you haven't received any SMS or any mail from these guys. Maybe that point in time they are down. So technically, what I'm talking about, this is the big challenge we have. Okay, where if one service want to commit other service to share some information, so they accordingly this destination service will do something for us. And if your service is tightly coupled, then this kind of challenge we will face. So how to overcome this challenge? To overcome this challenge, right, and to solve this kind of use case, normally we do, and this is a very common architecture we have. So wherever you have two services, okay, so we don't want these two services can directly communicate to each other because there might be possibility that their destination may be down. Okay, that point in time. So because our final requirement is to A has to send some data or the information to the B. Okay, so what can we do? Rather than we send this information directly, now we can add some middle component in between, or middle program in between. Okay, and now I'll say A, do one thing, whatever data you want to send to B, send this data to this program. And the duty of this program is to send this data or information to B. Okay, here the data and information is known as message. So I'll tell them A that whatever message you would like to send to the destination B, send to this system or this VM or this program, and this program will send this to B. You don't send directly to B. Why so? There's a lot of reason for this. One of the reason is this program, what I highlighted in this blue box, is very much reliable. Okay, and why is reliable? Because it's not only one single VM is running. Maybe we have launched multiple virtual machine behind this. So it is a cluster of program, and we are so much guaranteed that this program is very much highly available. If due to one of the VM goes down, we have a this virtual machine or this setup always ready for you. and and why we are so much guaranteed? Because this is the program managed by the cloud guys, and they are giving us a guarantee, right, that they have launched multiple virtual machine and they are giving a guarantee of highly availability. So this is the cloud managed program. Okay, and they are managing all the internal part of this. The only thing that you have to do, you have to send the messages, they receive the messages, and wherever you ask them to send these messages to somebody, this program will send the message to this guy. Okay, this is one thing. Okay, but one more beautiful part of this program is what a message you send to this program. And guys, that is the reason it's called message program, right? Or messaging program maybe sometime. So the beautiful part of this program is whatever message you send, they will manage your messages or the information in a queue. Right? So what I mean by this, for example, A say I want to send a message to B. They send the message. For example, let's say my message is that you bought one product called product number 2. Okay, so this information they store in their some storage in some this called queue. Okay, and then this system will send a message to this program number B. But there might be possibility and there was a big challenge we was talking about. This VM is down that point in time. And this VM is down, so there's nobody here who are going to use this information or technically called consume this information. Because that system is down. Okay, so this program, right, will maintain the queue there, maintain the information there till the time this system don't come back. Okay, maybe after 20 minutes or 1 day, 2 day. Obviously, guys, your main program never gonna down for 2 days or 1 day. If something goes down, you have a team, they keep on checking about, or they have some kind of backup system. they quickly restore from the backup and something like this. But maybe they're down for 2 minutes or 10 minutes, right? After this program come back, okay, somehow we come to know, and this program will go and retrieve whatever the message they have in their queue. They download this message, they download the information and do whatever they wanted to do here. Okay, and that easy reason, guys, this program is known as message queue program. So message queue is a concept, right, that help in this kind of scenario where A want to communicate to C, A want to communicate to B, right? So now, rather than they directly communicate, now between A and B or A and C, we put one component and one server. This is called a message queue. So they will send the message here. They store the data in the queue, and then this data will be finally used by or consumed by B. And that easy reason, guys, this destination computer is normally known as consumers. So B and C here, the consumer, they consume this data and information. And because this information is generated by A or produced by A, so this source system is normally known as a producer. So producer and the consumer is very commonly used technical term in this world. So I can say A would be the producer here, or C and B both would be the consumer here. And maybe you have hundreds of more consumer. So it has some data information they want to send to multiple system also. Okay, so they can send in one time. So this is again one more benefit they have. So if A want to send the data to SMS, to email, to databases, or to maybe some other services, right? They just produce only once, and after they produce, they can send this data to multiple destination computer or the multiple computer, and everybody can consume it the way they want to consume. For example, A will get this data to send the mail, B will get this data, B will get the data sent to mail, C will get the data to store in database, and something like this. So multiple guys consume this and they do whatever they want to do on this data. So technically, so what is the challenge? And now in this case, if any of your destination is down, and after they come back, so whatever A want to send to this guy, they want to lose this message, they will retrieve from, or they will consume from the message queue program. So what is message queue? It is one kind of server, one kind of program, one kind of software. Okay, and they have some internal storage, and I can say this storage is some kind of persistent storage where they can persistently keep your data in some box, and this box is normally known as queue. In some kind of queue. Okay, so so guys, this is the way the thing work. And in this architecture, now we don't have a and B directly connected. We put some middle program behind this, and this is the reason, guys, this middle program is come into the category of middleware. So this kind of program is coming to the middleware. You know, we have a software, we have hardware, and we have one kind of layer in the technological world that is called middleware. Guys, can you hold for a second, please? So that's called middleware. So by this, what happened now, A is not directly connected to B, and this guys concept is called, now we had a tightly coupled, now we have decoupled A and B. So guys, whenever you heard this term decoupled, it means now A and B is not directly coupled, right? So now it is like a dynamic dynamic kind of setup. Due to some reason, my database goes down. Okay, your front end is keep on working. So maybe A is a front end, B is your back end. You know, maybe some of the classes I took example of WordPress, or maybe MySQL database. There, if a MySQL database goes down, your front end fail, right? But because of this decoupled nature, every program or one single application is been it's been treated as an independent program. If B is down, is keep on working. They keep on getting the information from the client, from the user and customer, and whatever the information they are capturing. And if they want to send this information to other program, they send in some centralized message queue or some centralized storage. Okay. And from there, when the B come up and again come up, they will consume this message. Okay, maybe maybe sometime it is very much confusing thing, right? Instead of message queue, can we put our database servers also here? Because guys, so sorry, I'm so sorry for that. So can we put a database server also here? So I've seen sometime, it's not obviously a good practice, but you can use the A is one service, B is one more service, right? And what A want to send to B, they will put first thing in your database, for example, MySQL, MySQL, and we will get the information from here. Same kind of thing you can achieve by this kind of architecture also. We can go for typical normal databases services to do it. So if you have database already, so why we need some middleware kind of program or message queue kind of program? The one of the biggest reason is this program is very slow, very slow. Okay, I want to achieve a program. I want to achieve a program that will give me a feeling that A and B, that you guys are directly connected with the wire. So I want a program that work like the speed of wire. Means as soon as A send the data to over here, B will same time consume it. I don't want any kind of delay and latency in between. So we have to use a certain kind of a program in the middle that will store our data permanent, the way database store. But they give me a feeling that there's no program in between, and they are super fast as like that we are directly communicating to each other. And that is the reason we have created some kind of specialized kind of database. And the database is not actually known as database. This program is called message queue kind of program. So somehow they have functioning like database that we store our data for persistent for some time, right? But they are super fast. So that is the reason. That is the reason. If you guys ever see anything about message queue, they always talk about the speed and the performance, and normally they use the word called throughput. They always say our throughput is super fast. In 1 second, thousands and thousands and millions of data we can store, we can receive, we can send. Okay, they always talk about the throughput because they are super fast. It is like it's something like a wire. It look like there is no program in between, but they might have some small delay, but if you compare with some other stories, they are very fast. Okay, so what is message queue? It is just a program, okay, where they get the message stored in their storage, right? And obviously guys, this message we use for some purpose, right? It is not like this we have to store this message forever. Important point here is, if you take about this example, if some customer buy some product, this program come to know this product has been successfully processed. That point in time, I want some information will go to my MySQL or my email so that they can send it. So this information I have to keep for some time. Okay, I want permanent. Why? Because my destination system might be down. I need for some permanent, but not like this for forever. And that is the reason whenever you go for any message queue kind of database, first of all guys, these are not database, but if you go to any kind of message queue database, they keep your data for some time, maybe for 1 minute, 2 minutes, and some time, maybe some days. Okay, for example, right now message queue is just a concept, and if you want to implement the message queue, then AWS cloud has given you one service that's called SQS. They go simple queue services. So by this SQS you can configure the message queue. So in the SQS services, they have, I think 14 days is a maximum time where they can persist your data. And that is too much actually. Obviously, your destination never be down for 14 days, right? Obviously, if your mail server or database server down, you have engineers, they will go and check what the challenge, or maybe they will troubleshoot in a day or 2 days or maybe 10 days, maybe 5 days, I can say. Okay, but even though here they give you a limit of retention of your data or retention of your message. Retention means how much time they keep this message in their database. So I think the maximum limit is 14 days, but we can change if you think you don't want to keep for long. Okay, there's a different point. Okay, so so I think you got the idea, and you know this is the way it works, and this might be one of the time the reason, guys. You know, sometime you will see if you buy some item from Amazon and some like of this site. Sometime you see as soon as you buy the item, you get the message. As soon as you buy the item, you get the mail, and sometime you buy the item right now, after 2 minutes, after 1 minute, after maybe 1 hour, you might get the message from these guys. And not only about message, maybe sometime they create an invoice for you, sometime they do some more things for you, so it might take some time. And reason might be reason might be that point in time, maybe my mail server who sent the message is down. Okay, or maybe whatever the message we are storing in the queue, they are very much populated with lots of messages, because a lot of transaction is going on. So they have, you know, we have some kind of limit here for number of throughput, you know, how much data we can or message we can pass. So we will see all the thing about. So it is about the design and how you create this structure. But in the simple term, okay, message queue is a middleware. Normally we put message queue between two programs of a single application. Normally I can say, so this is one single application and there's a lot of program running behind the scene. Okay, and this program may be microservices. So there's a lot of microservices running behind the scene, and in between we put this message queue that is called a middleware kind of program, but it is just a concept. Okay, and for implement the message queue, there is a lot of product available in the market. Okay, there are a lot of product available in market that through which you can implement the message queue. So one of the product is called RabbitMQ, is one open source product, right, through which you can implement this server or this program. One is Apache MQ, one is Active MQ, right? Like this, there's a lot of product available. One is Kafka, a very familiar known product. So these are a lot of product, and and mostly these products are open source product. So it's free and you can install and set up your own message queue. But only challenge is if you want to use RabbitMQ as a product, then you have to launch your OS, you have to configure by yourself, everything you have to manage. Okay, but if you want, right, if you want any managed message queue services that we don't have to worry about, that we have to use RabbitMQ or we have to use Kafka as a product, right, from underlying hardware to older you know, scaling part. If you have suddenly load increase, okay, you know, maybe I have a message queue system and a lot of transactions going on, is keep on sending a data to this message queue, and maybe in one system might not able to accommodate all this messages. So I want to launch one more, then one more. So a cluster of message queue I want to create is like auto scaling. Okay, so I want somebody manage the auto scaling for me, and security and everything, you know, upgrade and security patches, everything they do for me in the message queue part. So there we have to use go for managed services. And normally guys, managed services from the cloud, and in the AWS cloud, the name of the managed service is called SQS. This is simple queue services. So there's more lot of options available. Which one you want to use, that would be your choice. But if you go for SQS, it's a pure managed pure managed services by the AWS. And that is very much useful into decoupling your program or maybe microservices. Even though I can I can say if you're working on the microservices without having without having decoupling or without having message queue, none of the microservices properly work for us. So it's a very common thing in the microservices world if you know about microservices, but this is the way it works. Okay. So so if you guys talk about scalability is elastic. So as soon as the more and more messages come up, automatically they increase the cluster, they decrease the cluster. So everything is purely managed by managed by AWS guys. And these are the clients and use cases, case studies you can see about uh, SQS service. And it is one of the main oldest service in the AWS world, very reliable, very powerful. And a lot of company has their personal case studies on SQS. SNS is different thing. What is SNS? We'll discuss. And there's one more service recently they launched. It's called Message Queue. It's an independent message queue service by Amazon. They launched. What is this? This one we will discuss. So this one service we're discussing right now. So let's first complete SQS, then we'll go to other services. Okay. So I think this concept is clear. Let me show you how the thing works. So in the guys message queue world, you have to know just one thing. Okay, one thing, that anybody or any program, if they want to communicate with other program in any sense. Okay, so this program is normally known as producer. This program is normally known as consumer. Okay, and what are the information or data they want to send to be, they have to first send to this program or this database. Okay, here this database is not known as database. Here this database is known as queue. They have to send to this queue. So this queue first store this message in their personal storage as a persistent. Okay, and then they store only here. Now it is duty of this B that they keep on checking, do you have and do they have any message for a B. And understand one thing, it is not like worked like this. Like for example, as soon as A sends some data, for example, A say that somebody bought a product, right? Product that says ID equal to. So this information guys we store in their storage, where in the queue. Okay, that's all. And then the duty of this program is done. Duty of this program is message queue program is done. Now here B has to come and keep on checking. So in the B we have a program maybe written Java, Ruby, or maybe Python. So this Python program is keep on checking, keep on checking that do you have some information for me? Do you have some message for me? Do you have some kind of data for me? So this program is keep on running. You can think as in a loop. And this keep on checking is known as poll. So they keep on polling the queue again and again. And as soon as they find some new information come for the B, then they download this information. It's called, they consume this information. Okay. So technically here in this example or this kind of publisher, producer, consumer kind of this architecture, after we put the data in the queue, they will never tell the B that somebody, some information will come up. B has to keep on coming. So way you write the program, okay, and they have to keep on going and keep on polling, does I have some information or not, right? If you have, then you just go and download, means you have to consume this information. After consume, this is normal data. You can store this data in some variable. And now with this data, whatever you want to do, you might retrieve the email ID from this. Okay. And send the email. You might put some product number, so amount they can put in the databases, depend what kind of this service is going on, what kind of program is going on. Okay. So this is what it is working. And that is the reason, guys, if you go to message queue, normally we have to create a database. This is called queue. And that's what guys they are talking about. So I'm into the SQS. Okay. So let me again start. This is my SQS. And if you guys see, this is a very commonly seen diagram. So this is the producer who sent the message from the application, maybe from microservices, maybe from some other AWS services, and consumer are the one who process the data message. Okay, process means if you B is a program who will go and download this information, this message, and after they after they download, there's one thing they do. Okay, they use this information to send mail or something like this. Means they do a process. Okay, instead of use process, I can use the word called use. They use it. Okay, and after they use, they say now whatever message come for me, I already downloaded, I already use it. Now I don't want to store this message now. I just want to delete this. So then finally they will delete. Who will delete? This B is a program who did, because this is the guy who know that the information that is being sent by A have the consume or not. So this three things they do behind the scene. One, they download, then they use, and then they delete. This entire three process called processing. So when we use the word process here, it means they download and they use, and finally after they use the way they want, they finally delete. So message has been processed means this is done. And why so is important to delete? I will explain you about this concept. It's very important. If you don't properly delete this, then maybe some kind of further issues might generate. So when I say it's process, it means they they delete it for us. Okay, so this is one thing. And what is SQSQ? This queue store message and wait for consumer to poll. Okay, so understand one thing. Whenever the message is stored in the queue, okay, they won't update the consumer that something come for us. Consumer has to come and they poll. Poll means they have to download the message. Okay, but there's one more kind of architecture. This is called pub sub. What is this? We will discuss in some time. Where there's the architecture is a little bit different. What I mean by this, we'll discuss there. But in this architecture of producer and the consumer, consumer has to come to this database called queue and download their message. Okay, and this SQS queue is created by Amazon SQS service. Okay, so that's what it's working. So this is one thing. And if you talk about the durability, availability, they are very highly durable because purely managed services. So there is no as such challenge come up in the terms of durability and the availability of this service. Okay. Now let's go and create a queue. Right. Those who are not able to properly, they might be first time you guys not able to properly, grasp this word. So you can think queue is equals to database. So we are creating a queue over here. Okay, now there's two different kind of queue we have. One is standard and one is FIFO. What is the difference? I will explain you in a minute. But let me give my database name or my queue name. Let's say it's my Q1. So this is the queue I am going to create. And guys, here they're talking about the message retention. Okay, so minimum at least they keep the message for 1 minute, or maximum they keep the message for 14 days, because it's not a pure database. I don't want to keep my message forever. As my consumer consume. Okay, right now they might not be able to consume because maybe they might down, but after it if they come up, they will go and consume this message. Okay, so that is a retention period. 4 days is more than enough, but if you can make it down for hours, that is also very much okay. Okay. Second thing. Okay, and because this program is meant to exchange the information between A and B. So this is a kind of intermediate program or middleware kind of program. So because you're sending the information, and normally the information is not normally in big in size, maybe half page information, maybe, or 2-page information. So normally the information is not so much big. It is not like this. We are sharing the images in the videos. We are just sharing the metadata or the information. And that is the reason. Okay, the size of the information or size of the message is very limited here. Okay. So the minimum size is 1 KB. Okay, and maximum is 256 KB they allow. So this maximum size they allow. Okay, and one more reason why they keep the size limit, because intention here is because they have to store the data somewhere. Okay, so they have to improve the the throughput of your storage or your process. Okay, so bigger the size they allow, maybe it will take delay, but technically in this kind of use case we never have so much bigger bigger size of information want to exchange. So 256 is again more than enough to send SMS, sorry, send some information from A to B. Okay, so this is one thing. What is visibility timeout? Very interesting concept. I will explain you. What is delivery delay? I will also explain you. We'll discuss in summit, but at least these two concept, guys, you understood. I'm not changing anything. I keep this information as it is. Okay. Now this is about access policy. It is something like a IAM. So who are going to use this queue? So let's say they have allow only the owner of this queue. Right now, this is my account and I am the owner of this queue. So the the sorry the whatever message we are going to send and we are going to receive, so only from my account I am the one who can use it. But we have some other use case come up. I show you guys some example today how to integrate this guy with Lambda. Okay, and Lambda is a different service altogether. So how Lambda will use, so we have to do some changes in the policy. Okay, right now I'm not changing anything. I'm just keeping like this. Okay, and this is guys encryption. Encryption, you guys know. So obviously guys, if you see here, two places where I need the encryption. For example, if A want to send some data to this server and this server want to send some data to this system, so my data is going via network. So if you want water data going inside your network or via network in a packet, do you want to encrypt this? This is called in transit data. So in transit data, do you want to encrypt? So if you see guys here, so by default in transit in encrypted. So you don't have to do anything else. It is a by default nature of SQL service. They will by default encrypt your data. But after data reach to message queue, they store this message and data in the storage. Okay, that is called data at rest. So do you want to encrypt your data at rest? So that is the functionality they are asking. At rest, do you want to encrypt this? So there is a by default disable, but if you want to encrypt, you can click enable and it will be encrypted for you. Okay, if you click enable, the encrypt for you. And for encryption, you need some kind of public key, private key pairs. So for this, there's a CMK, KMS. So what is this kind of encryption service? It's a little bit, we will discuss in a little bit advance in my encryption topic. So I'm leaving this topic right now. Okay, let me disable this, but these is options they have available. Okay. And there's one more concept is called DLQ. What is DLQ? In a minute, I am going to explain you. Okay, it is disabled by default, but what is the meaning of DMQ? So DLQ, I will explain you. So technically in this screen, I haven't changed anything much. Nothing I changed. I just given the name of my queue. That's the only thing I have done here. And let me go and click my queue. So guys, finally one click, your queue has been created, and it's purely managed queue. All the server behind the scene, they have an instance, RAM, CPU, cluster of message queue. Everything is purely managed by AWS, guys. So it's purely serverless topic it is. Because there's no server, you can't see any server here. So SQS is one more example of serverless serverless topic. So it's a serverless service from the Amazon side. Okay. Now, if you see here, what is subscription, we will see. We will talk about guys these topic in a minute. But if you click on monitoring, okay, so this is the metrics or graph come by default from CloudWatch. And if you see here, they will talk about number of messages we have here, the oldest message we have. And guys, understand one thing. This is a great way to troubleshoot the things. Okay, whenever I see any oldest message, for example, if a message is older than 1 day and older than 2 days, it is but obvious why a message is older. Okay, obviously my consumer is not going to consume this. So maybe there might be possibility my B is down. or my consumer is down, and that is the reason they are not able to consume it, or because they are not able to consume a message, and that is the reason my message become older and older. But if B consume this message, obviously after consume, normally they delete this. Right? We have option, we can't, we, if you don't want to delete, we can also not delete, but normally in processing, we delete this. So there's no meaning that my message become older. So this is a kind of good graph. By this, we can see we have some messages in order. So we just go and troubleshoot why they are older, which particular consumer are not going to consume. How number of message we receive, number of message we delete, send message size. So these are the very great graph you can see. Right now, nothing is there, no data available because we haven't done any transaction between A and B. Okay. So this is one great graph. Now, important point, guys, here is, okay, normally message queue is a topic. Normally this topic we use in the, this kind of server is purely used by the developers. So maybe I have a developer who write this kind of A as a producer program. They also write one more program. It's called B as a receiver program or consumer program. And my developer has write some code in some Java and Python, and they keep on sending the message in the message queue. And they write one more code in the B, and this guy will keep on downloading and consuming the message from message queue. So this kind of product, guys, is normally, if you want to test everything is working great or not, so you have to create producer program in some language, and you have to create consumer program in some language. Okay, but Amazon has given you us a one testing tool. They have provided A program also, B program also, so that we can test our message queue that everything is working properly or not. Otherwise, in our application, whatever the language you know, every language has support for this. Okay, for producer and consumer, you can write your code, who will send and who will receive the data for you. But if you want to test your message queue is properly working or not, so in your SQS, right, if you see here, this is the queue you have created. Okay, and right now we see there is no message available. Okay, because we haven't sent anything yet. But if you go inside this guy, they have given us a tool for testing, and if it's in the top, send and receive message. Okay, and if you click here, here you can ask what message to send. So this is the screen that you're seeing right now till here. It is a sender program, or I can say this is a producer program. It's like it's just tool for testing. Obviously, we are not going to use this tool in our real application. Okay, so what I'm doing, I'm testing and say this is my first message. Okay, maybe somehow somebody also create a chat program also with this message queue. Even though chat, we have a different set of tool and protocols available for chatting, right? But we can also create chat program also by this. Okay, but right now this is my first message we are sending. Okay, and we are sending. Okay, so technically this is the message we are sending, and finally message will store in the message queue. Okay, so let me send. So this part is done. My message has been sent and is ready to receive. It means they already sent in the message queue is stored in the queue and is ready to receive. They say they are ready to receive. It means B has to come to message queue and consume it. Okay, and they have given B a consume program. So if you go down, okay, and you see this is the message queue, and they say my message is there in the message queue. Okay, so my message there, but somebody has to come to receive it, and receive means poll this message. And guys, if you so go down, this screen is about a consumer. Or my consumer is not yet actually polled, not yet downloaded. So so message is not yet being processed, and it's still there in the queue. Okay, so this is one thing. But if you again go back, in your queue, okay, and if you refresh, so you can see message is available. One message is available in your database or in your queue. Okay, and why is available? Because none of the consumer yet go and process this message. Okay, but if you want to test this, so again you go down and they send and receive. If you go down, and there is option called poll the message. So this guy's screen, you can think it is a screen for a consumer. Or you can think somebody written some Python code and they put the Python code in a loop. And what this Python code is doing, they keep on going, keep on going, keep on going and asking, do you have any message? Do you have any message? Do you have any message? If yes, they poll it. Okay, so do you want to start this consume program? Just click over here and guys here, polling progress start. Okay, means they keep on going. And because right now they keep on going, so what they found, they find one message available and they download this message. So they download one message, and okay, and the size of the message is 18 bytes. They know they're given some ID to this message, but if you click in this message, you can see the body part of the message. So whatever the producer has sent, the consumer program has received this. Or maybe you can see the detail here. They show you 18 size, how much data they receive, when they send, when they receive, and all the other things you can see here. Okay, this is one thing. So the polling process has done. Now understand one thing. If I again go to my queue, again I receive, again refresh, you will see message is still exist in the queue. Okay, it still exists in the queue. What I mean by this, okay, the meaning by this is after A sends some data, this message queue store this data in their database or in the storage. It is called in the queue. And they say the B program or consumer has to come and process it. And process means, guys, I already told you, process means first they have to download, they have to use, and then delete. So right now my consume program only downloaded and only used. They haven't deleted yet. Okay. So if you guys see here, again, if I go inside the send and receive program, so my receiver program means my consumer, okay, they only downloaded, they haven't deleted yet. What I mean by this, if you again poll, the message again come in. Okay, and again see the same message. Okay, the bad thing about here is, right, this feature I don't want, because you know, if you see the receive count is 2, it means your consumer program receives same message 2 times. Okay, why? Because my message is it's still available in the storage, in the queue. And because they receive 2 times, it means, again, if you go to this diagram, it means the same, my program, let's say B here, there's an email program. And if they receive same email ID 2 times, so they will mail 2 times. You know, sometimes you see some of the website, when you purchase something, you receive multiple mails, you will receive multiple SMS, same thing. Why? Because whatever email ID we store in the queue, they retrieve, they send the mail, again retrieve, they send the mail, again retrieve, they send the mail. Or because they keep on retrieving same email ID or same message again and again, they keep on sending the mail and mail and mail. So for SMS and email, that's very much okay. But if you talk about the database world where they keep on putting your inventory, what item you purchase. Obviously, guys, it's very risky for the business. Okay, I don't want to put this product purchase one time, this product purchase one more time. So you pay for one time and they store multiple times. So it's not good for their business maybe. Okay, so it's very much critical thing. Okay, now if you see one more time they receive. Because all operations keep on running and they receive one more time. And even though if I run one more time, they receive one more time. This is why. Okay, this is because of 2 reasons. Okay, one reason is because my time for for storing the data in the storage that we have set is 4 days. Means if you again go back to your message queue, and we have mentioned already here that I keep my message for 4 days. It means your message will be there for 4 days. And how much time consumer want to consume this message, they keep on consuming. They keep on consuming same message hundreds and thousands of times in the 4 days. So either you decrease the time, but if you decrease the time, guys, you will stuck in one thing. Okay, you're stuck in one time. Maybe let's say you decrease time in 1 second. Okay, so maybe if you decrease your time 1 second, it means your message will be there in the message queue 1 second. But that point in time, if your consumer computer goes down for 2 days. So what a message we said send in this queue, my consume program never gonna process this. So again, it is very risky for the business. So technically, I don't want to change my retention time. Okay, we don't want to change this. So what can we do here? What can we do here? So technically, your SQS service is your message queue service. They have come up with some kind of facility, and facility is, okay, this message queue program here is called SQS. They say we support one concept, and this concept is called delete. Okay, so you are the consumer. You decide after download, after you use, do you want to use it again? Or if you don't want to use, you can delete this. So from your system, you can send a instruction to my queue and say you want to delete this message. You don't want to use further this message, because whatever they want to use for sending email, putting database, this part is done from your side. Okay, so message queue guys never delete the message till the retention time. So your consumer program has to write in the code when they want to delete it. And for this, your message queue program has given one API for the delete, means one kind of function they have given for the delete. So very quickly, if you search the AWS SQS delete message API, so one kind of function they have is called delete message API. Okay, and obviously guys, you have to write this code in your program of Python or Java and say, after we download this message, we will use this message, and after the message been used, then we'll send this signal. Okay, so this signal, and we ask this guy to delete this. So in some of the code in your respective language, you have to write that you want to delete this queue. Okay, but you have to write by yourself, otherwise this kind of issue come up. Okay, so you decide what facility you want. But guys, in this example, because we are using the testing application from the AWS side. So if you want to delete this message, even though if I see here, if again Paul again come fifth time they come up. So the download we see this data. Okay, but because this is the consumer application, we have to send the instruction that we would like to delete this guy. And for this, we're pretty simple right now here. Just click and send a delete instruction. Do you want to delete? I say yes. Okay, so this is called guys complete processing. So you download it, you use, and then you send the signal delete. Right now, guys, again I'm saying this is a simulated application here. It's not the real application, just for testing. But in your code, find in the application, the guy who write your application of A and B, they will have to send this delete. Otherwise, you stuck in this kind of big challenges. Okay. And now if you see guys, there's no message available in the queue. So we don't have to wait for 4 days, right? You send the delete signal and they delete for you. Even though if you go again to queue, if you again refresh, there's no message available. So this message has been zero from here. And if you again go and to your consumer application and try to poll again, there's no message they are polling. Okay, so guys, that is the meaning of this delete. So when we say something process, and normally we mean to say download, use, and delete. But delete, we have to exclusively say that I want to delete this message. Okay, but understand one thing, it's not a small thing, it's a lot of big issue you will face if you don't delete it and if you consume this message multiple times. Okay, this is one thing. Now one more thing guys here to understand. Okay, the concept is if you again go to this queue, okay, and if you see the detail of this queue in the more, okay, there's a concept called visibility timeout. Okay, which is timeout. So what do you mean by visibility timeout? So it is a concept something like this. Okay, because this is very common architecture we have. Okay, architecture we have. So architecture would be something like this. For example, when client connect to your front end, here the front end, let's say, is A, right? And A is the one who do some processing. They generate some information. They generate some data. Means they are the producer program, and the producer program want to send something to the backend. Let's say this is B, okay, and they send via message queue. Okay, so they put in this queue and we will go and download and consume this. Okay, but normally guys, in the bigger environment, it is very common that we don't have only one single V, we have lots of same computer running in parallel. So this is where you have one more V, one more program, one more program. Every program is doing something for you. So all the program is doing mailing. All the program is a cluster for your MySQL database. So a lot of system guys running behind the scene. Why? Because they have hundreds of thousands of messages keep on coming. Not one single system can process all the backend activities or all the messages. So we have a lot of system we put behind the load balancer. So we have some kind of load balancer here or private load balancer here, and behind the load balancer guys, these guys are connected. Okay, so technically, again, if you create this diagram a little bit more clear, it is something like this. So we have a front end. Again, guys, we also have multiple front end, not single front end, because maybe for my internet, hundreds and thousands of public guys want to connect. So we also put one load balancer here. It's called ELB or ALB load balancer, or this is a public load balancer we have. So my client will always connect to this public load balancer, and this public load balancer will either send to this guy, this guy, this guy. All the guys have same front-end application run. Okay, but let's say they connect to A. In this case, they connect to A. They do the order. They do their processing. Okay. Now A want to communicate to B. Again, we have a lot of backend system running for the mailing, for databases. Let's say through 3 and 4 computer running behind the scene, and everybody is doing the same thing. So let's say this is the 1, 2, 3, and 4. Everybody is doing the same thing. Is a replica copy of this. So I want whatever A is sending, they will go to any of the computer, but only to one computer. Okay. And for this, we put again one more load balancer. And this is the backend system. So we don't have to go for public load balancer. Here we can go for private load balancer, and you guys know how to create a private load balancer. Okay. So any message come to this guy, either we send here or here or here, but only to one computer, because all the computer is doing the same thing. Okay. Let's say everyone is the mail server. Okay. But connecting to A to these guys, we have to put some message. Okay. So let's say it's something like this. If outside client want to connect your website, your load balancer will connect to A. They do some process, order done, successful. A then send this information to the message queue. Then the part of A is done. So A say I am free because this is a decoupled kind of setup. So I don't know about backend. They are up or down. I don't have to worry about whatever I've done. I have put in my message queue. I'm free. I keep on doing my further task. Okay. So this part is done. Okay. Now this message queue will contact to this load balancer, and wherever this load balancer want to connect, they will further connect to, let's say, this mail server. Okay. And they send to this mail server. Now point guys, what is in this architecture? This is very commonly real kind of architecture we always have. Okay. So guys, in this kind of architecture, what challenge you will face? So these guys say, I am a mail server. Finally, I'm the destination computer. I am the consumer. So I need some information. So these guys go back to message queue, download the message. Okay. What they do, again, the same thing. They first download the message. Second thing, after download the message, they do some process on the message. Maybe they are doing some filtering. They are doing some kind of further processing. They are sending the mail. they are doing something. Okay. And after they done all this process, then only finally they delete it. If they don't delete, I told you the challenge, what will come up. The challenge, what they come up. But what I'm trying to tell you here is, here, for example, this program, first they download. Let's say it take 1 second. Then they start processing. Okay. Maybe processing might take 10 seconds. But till my process done, till my mail sending is done, I don't want to delete this data. Maybe while processing, my system goes down. Maybe. So I can't take a risk that while processing, I would like to delete my data or my message here. Okay, so I will only delete my message only if my entire process is done. Maybe you can write some if or else. If your entire process is done, then only just go and delete this message. Something like this code you can create while writing the code. Okay, but in this scenario, because all the system are the consumers. This is also consumer. This is also exactly same consumer. This is also exactly same consumer. What happened? Okay, because all the consumers keep on polling the message, keep on polling the message, or because all the consumers are same, so there's my possibility this consumer poll the message, and this consumer again poll the same message. For example, this is a client, let's say the email ID is vimal at gmail.com. We put this email ID in message queue, and my consumer will download, first consumer download the email address, maybe same point in time, because same consumer, their same copy in the different computer, they also polling the same thing, and they again poll the the same message. Again, all the four guys poll the same message. It means all the four computer behind the scene will do the same thing. They will send 4 times mails over here in the same area. So it's not the right way I want to do here. Okay. So technically what I want, by chance, any of the first guy over here, okay, poll the message. So I want that point in time, I don't want to delete my message, but after that poll, they are doing processing till the time process complete. I don't want to delete. So if first guy poll the message or download the message, I want to keep my message, but I don't want other guys will download the same message. Okay, so what you have to do, you have to make your message invisible for some time, invisible, okay, for some time. And that is the guys meaning of this visibility timeout. So as soon as one of the guys Paul downloaded, we make our message invisible for 30 seconds. Okay, so my message will be there in my storage, but it will be invisible for 30 seconds. So same kind of guys or maybe some other consumer won't download the same message. So there is a meaning of this invisibility or visibility timeout, right? They will make it invisible. And why do so? Because I don't want to delete. But maybe this is my first consumer, after the process for 10 seconds, then this thing is done, then they go and delete. After delete, none of the guys will go and receive the same message. Okay, so this was the meaning of visibility timeout. But this is the keyword that you might have to change. Is again vary from consumer program to consumer program. If you think your consumer program might, when processing, might take, let's say, 100 seconds. Okay, so after you download, 100 seconds they consume, but till the time they completely consume this message, like I can't delete. But here, according to my current setting, after 30 seconds, my message become again invisible. Oh, sorry, again visible. So my second consumer also consume this message and start doing the same thing. So you need to understand your backend application and to understand how much time your backend application gonna consume. Let's say if you think it might consume 100 seconds, so you can increase this timeout time for 120 seconds or maybe 200 seconds, something like this. Okay, so that is the meaning of this line. If you want to see this, I can very quickly show this demo. How? Let me open this page. And what I'm doing here, I'm trying to simulate the same environment. Let me open this page one more time. So let's say this is your, and let me open this page one more time. So let's say this is your sender, this is your producer program, and they are producing some message. Let's say this is a message 1 from producer. Okay, and we are sending some message. This message has been sent. Okay, and right now, guys, this is one of my, let's say, consumer, and this is my second consumer. And now the consumer guys get the message, because nobody go for poll, means they are not going there from themselves for downloading the message. But as soon as first one, let's say, start polling, the message downloaded. But here my message become invisible for 30 seconds. So it's my second guys or second consumer start polling. Again they wait, is hold. They're not able to poll. So my message there, okay, but second consumer is not able to poll because they make this message invisible for 30 seconds. And after 30 seconds, if my first guy want, this is polling duration. Okay, if my first guys feel that what a message they downloaded, they see the message, they use this message in some kind of program and they're happy, then they can go and delete. Okay, but they don't delete this message for 30 seconds. Okay, so maybe my second consumer will also receive it, they also receive after 30 seconds. But again, my message will again be disabled for or invisible for 30 seconds. But again, third one guys can also receive. Okay, so that's the guys meaning of invisibility. So it's all upon your requirement. Do you want to really want to delete? And if you don't want to delete, you want to keep it, for how long you want to keep it. So properly you can tune and change this timing. So in the message queue world, guys, this timing is very important because lots of challenges guys will face here. Okay, in this kind of world. Okay, challenge is my backend system will get this message multiple time, and multiple time you send SMS or send mail, and this is very common challenge you also see in normal world also, this kind of issues, right? Okay, this is one thing. So 1 minute, let me delete my message, otherwise they keep on polling. So after you receive, any of the consumer receive, any consumer can send the delete message API call and they can delete. After delete, nobody can able to poll. Okay, because we asked to the message queue to delete it from the storage. Okay, so it is something like this. Now there's one more concept guys here, and this concept will create some kind of some more kind of problem over here. Okay, so the problem would be something like this. But guys, before I explain you the problem, I want to tell you one more small thing here. Everybody know about load balancer, and everybody also know about auto scaling group. Okay, so guys, here in this kind of architecture, we can put auto scaling group for these guys. Okay, for front end. Okay, means we can tell my auto scaling group, just keep on monitoring these guys, keep on monitoring these guys. If they have more CPU or more RAM consume, launch one more computer, it's called scale out or maybe scale in. Okay, same thing, we can create an auto scaling group for my backend computer also, because these are also VMs or my EC2 instances or mail server or database server. We can add one more auto scaling for group for these guys. And again, we say if these guys have consumed more RAM and more CPU and more hard disk, launch one more. So what is auto scaling group? We have already discussed. But guys, in this example, we can add one more kind of auto scaling for in one more matrix. So we can tell my auto scaling group that if more and more messages keep on coming, because these computers are mainly used to consume the message and do something. They are sending SMS or mail. So we can tell my auto scaling group, do one thing, just keep on checking the message queue. And if you find there's, let's say we know by chance one computer can process 100 messages at a time or 100 email they can do at a time. Or right now we have 4 computers, means around 400 email we can do per second. but I can tell my auto scaling group that I am setting one metric in you from the cloud watch. And what I want, whenever you see more than 400 SMS, or sorry, more than 400 messages coming, okay, let's say 500. So obviously these computers won't able to accommodate all. They goes down, they become slow. So do one thing, automatically launch one more computer. So guys, this is again one more great use case of auto scaling group come up. So as more messages come up, launch more computer, less messages come up, decrease the number of computers, called scale. So this thing also guys, you can do in the auto scaling group, because in the auto scaling group, they ask you the cloud watch metrics. And this is one of the metric name in the cloud watch you can use for the message queue. Okay. This is very, very much commonly used use case that almost everywhere we normally implement. Okay, so let's talk guys one more concept in the message queue here. Technically, using the message queue is not a big deal. Very simple, but This concepts and this parameter is very important. Okay, so visible timeout, retention time, and delete. This is very critical. If you don't properly manage this, a lot of struggle and issue you will go and face. Okay. Then now we have one more challenge, guys. Here the challenge is something like this. Let's say this is a program who peruse the message, this is a program backend who consume the message, and this is the message queue we have. Okay. Now what happened, this program sent a message to this guy, and my consumer gonna go and download this message, and this is all purely based on the consumer, they want to download or not, means Paul. After download, what they want to do with the message, they want to print the message, retrieve the mobile number, retrieve the email address, they want to send the SMS or email. That would be pure their code, what they want to do with the message. A message like a string, what they want to do with the string. Okay, and then this their choice, they want to delete this message or not. So my developer has to write the code. After we process, we will delete the message. Okay, but let's say sometime there might be possibility by having some kind of buggy code, and some maybe by mistaken or maybe by intention, they write in the code to keep on polling the message, do something on this message, let's say send the email. Okay, but they forget to delete. Okay, they by intention or intentionally they forget to delete. Okay, so what happened, let's say we send the message at this time, let's say at morning 8 o'clock 15 minute 5 second. This is the first message we send. Okay, and this consumer program Paul and send the SMS on this message. After getting the email from this message, they send it. Okay, and I told you guys, after a consumer consume this message, the message become invisible for 30 seconds. Okay, till the time you delete, and this message keep for 4 days, for example. But 30 second, it invisible. It means the same consumer or maybe some other consumer, they want to consume. Everybody has to keep on polling. They can't consume and see this message. So it means 8 o'clock 15 minutes till 35 second, means 30 second, your message will be disabled. But after 35 second, your message again visible, same message one again visible to all the consumer or to the same consumer also, because the message is not yet deleted, but it's all been processed already. Or, all the email part is done. But because the message again visible, so this consumer feel is a new message come up. Again they go, again they download, because they keep on running in the loop. Again they send the mail. And again, because the consumer is done by download the message, the again message become invisible 30 seconds. Means after 30 seconds, means around 16:05, the message again disable, visible, and again again has been do the same thing. So sending email might be bother the customer, but something that is very critical, like storing this information in the database again and again, and billing the customer to again and again, it is not a, it would be very much critical for the business. Okay, and understand one thing, everywhere in banking, financial, other sector, message queue is a very common thing to exchange the message here and there. So it is a very critical thing. Okay, so you can think is a one kind of loop created. Loop created. Okay, and you know what guys, in this loop we have to terminate to this loop somewhere. Okay, loop somewhere. Okay, technically maybe the admin of this SQS, they might see this the same message keep on going from the portal over here, or maybe some kind of log, but they can't delete because I am the AWS guy. How I know this message sent by producer and consumer, they want this message or not? So we can't delete right from ourselves. Okay. So what can we do here? We can tag this message, right, after certain loop, or after certain time. If this message keep on going for 10 times or 100 times, let's do one thing: tag this message and say this message is dead. And we create separate storage for this message. This is called queue, and this queue, guys, queue is called dead letter queue. In the short form, it's called DLQ. Okay, so we don't store delete this message. Okay, we keep this message for ourselves so I can tell to their company, to this guys and developer, and they say, this is the message keep on going on, going on. This is intentionally you are doing, or maybe some part of the things you miss in the code. So put this message in some extra storage called queue, but by this, we can at least terminate this loop. So same thing won't do again and again. I got this concept is called dead letter queue, and this concept is by default disable here. Okay, so if you see here, in this queue, DLQ, dead letter queue is disabled. Okay, so undeliver message to the dead letter queue. Okay, so to create a dead letter queue, for this we can edit here. Okay, and over here we can create a dead letter queue, and we can enable this guy. Now what is asking you, choose the queue where you want to send this message. So if you think this kind of loop happen, and you have to terminate this loop, obviously you have to tell where you want to keep this message. So you have to create one more queue that will be known as a dead letter queue where you want to keep this message. So it is something like this. Right now I have this queue. This is my main queue. Okay, the queue name is called my Q1. So what can I do? We can create one more queue or one more extra storage. And let's say I'm giving you the storage name called dead letter queue for my Q1, or whatever name you want to give, that will be your choice. Okay, we give some new queue name. Okay, and just to show this demo, what I'm doing, I'm just doing a video time a little bit lesser, let's say 5 seconds. Okay, 5 seconds. So after 5 seconds, my message disable, again they poll, again disable, again they poll, they keep on doing, okay, they keep on doing, and actually for this is no, it would be not important, guys, to do this here. Normally this is dead letter queue. Maybe for troubleshooting purpose, you can increase the time of 15 minutes or for 14 days, for example, because in this in this queue or in this storage, we are keeping those messages that stuck in the loop. So we want to store this data for a long time, so we can show us to developer or my other teams so that they can further go and troubleshoot. So normally in the dead letter queue, we want to keep the message for a longer time. Maximum thing we can put for 14 days only, but 14 days is enough for the troubleshoot part. So this is the message queue we create only for storing some messages here. Otherwise, I'm not changing anything here. Okay, and I'm not enabling anything here because this is the by themselves dead letter queue. It's a normal queue, right? I can say. Now what I'm doing here in my first queue, I'm going here and I'm enabling dead letter queue. And say if any message is stuck here, okay, stuck here. So what to do? Send this message to the dead letter queue. Okay, so for this, I have to enable the dead letter queue here. Okay, and where you want to send, you want to send which one? So this is the one, queue I created extra. You see a DLB queue, and this is a full name of this guy is called ARN. What is ARN? So this is ARN of what I created. Okay, so for the first queue, that is the main queue, I have created extra queue to keep the looped kind of message here. But when to put here, how much try you want to do? So let's say I want users try for 10 times. If same message keep on going and process for 10 times without delete, so then put in the data queue. Or let me change here for 3 just for testing here. Okay, and one more small change I'm doing here is not obviously you don't have to do, but for demo I'm doing here. I'm changing the visibility time to, let's say, to 10 seconds. Why? Because first message I consume, then wait for 10 seconds, then consume, wait for 10 seconds, then consume, wait for 10 seconds. After 3 times, okay, they find there's a loop. Now this is the maximum threshold I have. means this guy is stuck in the loop, right? Somebody might be mistaken, might not able to delete this guy. So let's remove this loop after 3 counts and put this guy into the dead letter queue. Okay, so this is again good concept to implement sometime. Okay, so this part is done. So for this main queue where your producer is sending the message, your consumer is going to consume, we implemented dead letter queue, DLQ. Okay, so if you see guys, this has been implemented for 3 receives. And now if you again go, we have 2 queue. This is a main queue and this is only for any kind of data, right? Now anybody who send this message to this guy, let me again send, let's say testing for dead, for example. Okay, we're sending a message to this queue. 1 minute. Okay, the message has been sent. Now my consumer gonna poll this. So if they start polling, one time I received, after receive I might read this, it's called process, but I'm not deleting this. But they keep on polling, they keep on polling. After 10 seconds, after timeout, again they poll. Okay, they keep on polling, my message is invisible for 10 seconds. Again, after 10 seconds, again they poll. Again, message is invisible for 10 seconds. Again, if they try to poll, they see this is the maximum threshold happen. Now I can't poll more. It means we're stuck in the loop. Okay, and because we're stuck in the loop, so what you will see, what do you see? Okay, in this guys, we have a one message. Okay, and this message again over here. Okay, let me again refresh. And if you again see here, if you go to send and receive, this message is called by your consumer 3 times already. Let me poll one more time. Okay, now they are polling. They won't able to see this message. And guys, you see, without delete, I won't able to download this message. Okay, why? Because after 3 times, they see because same message we keep on downloading, might be stuck in the loop. So there's a maximum threshold we set for three times. They're not able to download this. It means this message, if you see here, this message, now whatever you have, if you see in the dead letter queue, because we have maximum 3 limit, so this message will be sent to the dead letter queue. So if I go to my queue, you can see guys, this message go to my dead letter queue after 3 attempts. Okay, and if you see in the dead letter queue, it's a separate queue, right? We got one message. And if you want to see from here, you can just go and check from here. After, you can also poll and check. You can see this message come up here, and it is exactly the same message. And this dead letter queue we will never provide to none of my consumer, so they won't consume this queue. We create this queue only for some kind of this issue of dead. Okay, and for troubleshooting, so we will provide this queue to my further developers and some troubleshooting guys. They'll see why this kind of message stuck in the loop. So that's what the use of this queue. Otherwise, this is the normal kind of queue, but we create separate queue for this purpose. Okay, so finally guys, message queue duty is to just keep the message, but these are the small very critical thing we have to think about to manage these things. Okay, this is some concept here, but let me guys show you some more interesting concept here. Okay, concept here guys, maybe there's one more concept called delivery delay. You can send. Okay, obviously guys, we are creating the message queue. I want, as soon as the message reach, I want to deliver in the same time. So by default delivery delay is 0 second, obviously, but there might be some use case, okay, where I want, as soon as the message come in my message queue, I don't want to deliver in the same time. I want my message to be there for 5 seconds, 10 seconds, 1 minute. After then I want to deliver to my consumer. So there might be some use case for this come up. So if you have some kind of use case you don't want to consume right now, Okay, maybe my producer, after they put the message here, they are doing something else, or that else might take 10 seconds more. So I want my message will be there for 10 seconds here, then only my consumer will do. Okay, so if anybody know about OAuth protocol or OpenID protocol, so they are the one who send the message in message queue, and they have to require some more extra time to do further processing. So there will be a lot of advanced use case for this, but it is very important feature and facility. Sometimes we have to implement. But right now it's by default 0, means as soon as they receive in the queue, my consumer can use in the same time. Okay, that's the meaning of this facility. Okay, otherwise all the major concept I explained to you, this topic is very important in implementing some real kind of application. This is the way we work. But anybody who are planning for AWS developer training and developer examination, so this is a very important topic there. And normally, because most of the guys are doing developer track also here, so I'm taking this, I already taking this topic in detail. Okay, because in the developer track, these kind of questions come, a lot of questions they come in the examination about SQS. Okay, so anybody who by chance not in the developer track, it is an extra bonus thing for you to understand these much topic. Because in the CSA training, we have very basic discussion on queue services, but I try to explain almost everything here. And the monitoring tab, if you see, we can see very clearly what is happening, number of messages we are having at this time. This is the oldest message we have. Number of messages we have deleted. Okay, number of messages we received, message sent, sign size. So cool graph, it's almost showing you what is happening. But in the real world, if you see in the real application, you can see the bigger graph on this, right? Thousands and thousands messages we receive per second basis, right? So the graph is very much critical to take some more decision in the terms of performance. Okay. Now, one more thing I want to show you, how can you integrate queue services with the Lambda. So what is Lambda? You guys know. Okay, so how to implement queue services with the Lambda. Let me show you guys one very interesting use case for this. Okay, so what can I do? We can create one function, and the function and service called Lambda here. You guys know in the last class we already discussed Lambda in very detail. Okay, so what can we do? Let's say let's say we have S3, we have a bucket here, and in the bucket, guys, we have set some event trigger, and we say as soon as some object we put here, I want to trigger and contact to this Lambda function, this called trigger, and run this Lambda function. And you guys know whenever run the Lambda function is called invocate. So invocation this Lambda function. Okay. So whatever guys we write in the Lambda function, that will be whatever we write in the code, that will be run. But we can do one more thing in the Lambda function. We say after you run the Lambda function, okay, and after you successfully run the Lambda function, okay, so we can set some rule here. After your Lambda function runs successful, then what to do? Okay, retrieve some data and send this data and store somewhere in my message queue. So I can tell my Lambda the contact to one of the SQS service and store some message there. Okay, and what do you store? Maybe you can store that my function runs successfully. And what your function is doing, maybe one function will go to the bucket, retrieve some data set, or maybe in the function they are doing some kind of processing on the data, cleaning of the data, and after function runs successfully. Okay, so we can add one more trigger in the Lambda and say after this function runs successful, in this case, contact to one of the queue. Let's say this queue name may be success queue, and put the message there that this part is done. And why I want to put the message in this queue? Because we might have one more consumer here. Okay, and this consumer is keep on looking for this queue, and as soon as they see this message sent by Lambda that this part is done, it means Lambda is trying to tell whatever data I put in the S3 bucket is been processed properly, maybe images or videos or cropping you're doing, image processing you're doing, video transformation you're doing, whatever doing is done successfully. So this consumer is a one kind of mail program, and they will retrieve this message and send the mail to their respective team that this process has been done successfully. Or maybe in the Lambda, we can do one more thing. If by chance some reason this process is not done successfully, then it will fail. Always two things will happen, either fail or success. If failure happen, then this also information also stored in some of the message queue. Let's say this message called fail queue. And we might have one more program running as a second program, and they keep on watching this queue. And when they find something come in the failure, they will notify, they will SMS, they will do some extra thing and connect to their respective team that something is failed. Or maybe they will do some more thing, depend what you want for that. So this kind of complete pipeline you can build. So in the Lambda perspective, guys, okay, whatever you connect as a trigger, these guys are known as source. But after Lambda process, either the successful or the failed, where you want to send this information to, this is called destination. So this is the very commonly used concept that we use in the Lambda. And this is a very commonly used concept where we want to integrate Lambda with the SQS services. So let me guys show you this demo. Half of the demo I already show you in my Lambda class, but let me very quickly show this demo. So I'm going to Lambda. Okay. So this is Lambda we have, and also going to S3. And this is S3 we have. Okay. So I'm directly going to Lambda, and I'm going to create a function over here. Okay. So this Lambda, I'm going to create a function. Okay. And let's say function name is called S3 function, something like this, that are going to integrate with SQ also. So this is a function name I am giving here. My code will be written in Python 3.8. Okay, there's a very straightforward, and one click, your function will be created. And now inside the function, whatever we want to do, right, that will be your choice. Okay. By the meantime, function create, I'll go to my S3 and I would like to set some kind of event trigger for, let's say, for this bucket. Okay. So what I want, as soon as some object upload in this bucket, I want to trigger something. Okay. So for this, you guys know from last class, we talk about properties. In the properties, we can go and set up some kind of event notification, event notification here. Okay. So some function we can trigger. So either you can create from here. Let me delete this. This is the older one. Okay. So either you create from here, and one more way we can create directly from Lambda also. And if you guys notice here, what we see in the left side is a source where we add the trigger, the way I explain you. And after Lambda function runs successfully or failure, in both the case, we have a destination on which Lambda further communicate to do what to do next. Okay, so let me add a trigger. And here I'm setting the trigger for S3. S3, which bucket? Let's say this is the bucket I want to use. And what I want as soon as somebody upload any object, okay, in this bucket, then only contact to this Lambda function or trigger my Lambda function. Okay, and let me acknowledge and add. So this has been connected. So either you can add the trigger from here, or you can add the trigger from here, is same thing. So even though if I refresh, you can see this option will come up here automatically. So I see automatically come up. So anybody who upload here, they will notify to the Lambda function and this one. Okay. And what is this? With this concept, guys, we already discussed in my last class. Okay. Now, if you talk about Lambda, if you talk about this Lambda, they're gonna run this function. Okay. So let me do one thing in this function. What I'm doing here, rather than have a lot of return, okay, let me print something. let's say I'm printing this is lambda test for SQL, something like this I'm writing here. So, but finally, whenever, let me deploy, whenever somebody run this function here, as S3 will run, this function will run. And you guys know, whenever lambda run the function, this information lambda is stored always in the CloudWatch log. So in the monitoring, they store in the CloudWatch log. So we click here. Okay. So in the CloudWatch log, they create a log stream and they put the information here. But right now, if you see in the log stream, we don't have anything because none of the function yet run. Okay. But I want one more thing here. There's a new thing today. I want my lambda do one thing. Okay. After you run your function, I don't know whatever code you write in the function. Obviously, this code is very simple. This code is always gonna run. But I want to set two more things. If this code runs successfully or unsuccessfully, in both the case, I want to do further things. Okay. And for this, I can add a destination here. And if you see here, a condition would be either fail or unsuccessful. And let me add success here. If your code runs successfully, then I want to connect to my further destination, and these are the destinations you have. You can further connect with one more lambda function. They will do something else, or maybe we can connect to SQSQ, and that's what I want. So lambda after successful connect to my SQS, it means send some message to the SQS. So in this case, guys, for this SQS, lambda function would be the producer. Will be producer. Okay, and for this, what I'm doing here, I go to my SQS, and in my SQS, sorry, I'm going to add one more queue, a new queue. Let me create a new queue here, and let me give the name of queue called, let's say, lambda success queue. What some name I'm giving here. Okay, so creating the queue is not a big deal, and this queue is created. But right now, if you see in this queue, refresh, I don't have any message. None of the producers send it, but right now in my case the producer will be lambda. And for this I have to go to lambda and say, let me refresh, that your destination would be this one. Let me again refresh, yeah, name come up, this one. So whenever your function runs successful, only on successful, then contact to this SQL service and upload the message to this guy. And understand one very small thing, lambda is a different service altogether. SQS is a different service altogether. And you guys know, whenever one service want to connect to other service, you need to create IAM role. Okay, and here the good thing is, they say IAM role doesn't exist, but as soon as save, I will automatically create IAM role for you. So you guys, you don't have to worry about IAM role. They will auto create for you. That's a good thing about this portal. Okay, so this part is done. So guys, this is a complete kind of pipeline we have created here. Okay, let's this guy save. It's taking some time because behind the scene they are creating the IAM role also for you. Okay, now this is the kind of setup we have done. Now what happened? As I upload something in S3, they run this function, is called trigger. And what do we have the function? What do we have in the function? They run. Okay. And after this function runs successful, only after successful, they contact to SQ. S means this one. Where it is? This one. And they post the message in the queue. And this SQS queue is being consumed by some other program running in EC2, maybe other thing, other someone. Okay, and that one is keep on seeing this queue, and as soon as they find some new information come up, they do further processing on this data. So lots of things we can connect like this. So what I'm doing here, okay, what I'm doing here, let me upload some new object in S3. Okay, so let me add new file. As I'm putting some of my image here. Okay, And as soon upload, this is called put request. And when guys anything you put in S3, S3 trigger the contact to Lambda, and it is but obvious. It is but obvious if you go to the monitoring tool of the Lambda. Here you will see. Okay, after some time something is come up. Right now if you want to quickly see, just click on seeing the CloudWatch log, that is I already opened, and last time it was not there. But if I again refresh, what you see in the CloudWatch, Lambda put the information, and you can see this one, the put one means Lambda function run one time. Okay, and if you click here, you can see this is the message I printed. This is the Lambda test for SQS. So this part done, we have done already, seen already. But as soon as this Lambda see this message and run this function, and by looking at the log, there is no error. It means the Lambda function run very much successful. It means my Lambda definitely contact to SQS. And because Lambda contact to SQS, so Lambda would be the producer for SQS. So this SQS queue, SQS queue, if I refresh here, last time it was 0 message. If I refresh here, you can see 1 message come up, and it works sure, but obviously it is coming from the Lambda. Okay, and if you click in this queue, okay, you can see 1 message come up here. Okay, plus if you want to see right now what message come up, you can use this testing tool, and you can make yourself and see 1 message there, and you can poll this message. Okay, and what you see here, this message come up. And what is come up? So Lambda sent this entire detail. That because of my condition success in my function of the Lambda, this is my function name. Okay, so so what I success, they give all the information that my S3 has upload this thing is a put object from one of the client IP of this one. Okay, and this in this bucket somebody has uploaded this photograph of this size. They put all the thing here, and this message guys is stored in the message queue. So I can use my consumer program who will get this information. This is JSON file, and they pick some of the information here and say if the file size is bigger than this one, then send the message to somebody an email that that is not supported. Of this file name, if it's supported, then just go to again S3, download this file and store it somewhere else. So a lot of other decisions you can pick and do here based on these information. Okay, this information guys they give you. Okay, so this kind of guys a way you can do it. But guys, again they keep on polling the message again and again. So you can just delete this from the queue. Okay, so that's how guys. So very interesting integration this one is, you can do it. And one more thing guys, by chance you can do. Okay, so in your message queue also, you can also add further trigger. And say if some message come in the message queue, let contact to Lambda again. And this is the different Lambda function. Okay, so from the queue perspective also we can add a trigger. So very quickly if I go here, so let's say this is a new queue, and I say if any message come in this queue, who will send? By chance Lambda is sending. Lambda, this function is sending. Okay, but as soon as some message come in this queue, okay, this queue also triggers some Lambda function. A Lambda function. Okay, and this Lambda function will be maybe the different Lambda function. So very quickly, very quickly, if you want to see this, let me create one more just for testing. Lambda function I'm creating. Let's say this is a function number 1. I'm running some again Python code. Okay, and that's all function created. And in this function, you guys might write this contact to SQS, download this message as a consumer, retrieve some details and send something. So something you can write in this function. Right now in this function, nothing special we have. Let me just print and say trigger from SQS as consumer. So I am a consumer. I trigger from SQS, something like this. I run it. Okay, and so it means in the SQS I can set for the Lambda function trigger, and the function name is this function one. That's all, pretty straightforward. Okay. Again, guys, for this, you have to create a role. Here, guys, they're not creating a role for you. In this case, SQS is the one who are connected to Lambda. Okay. So you have to create a role for SQS. That SQS, if you want to contact Lambda, you have a capability to role run the Lambda. So we have to create a role in the IAM role, and we can connect this, guys. But at least you guys got the idea how to create the role. You know this. You can go and create. Okay. So this is, guys, all about SQS. A lot of, guys, information I have shared with you, and a lot of integration we have discussed. Okay, I was planning to, guys, cover two more topic today. SNS or message queue is a new kind of tool from the Amazon. It's called message queue. Okay, so I think we won't able to touch and cover this topic. So let's just take this topic in my next class, where we'll cover SNS and message queue. And after you cover SNS, we can also integrate with SNS also with the queue services. Okay, so that's all. And there's one more option called purge. Purge means whatever message you have in the message queue, delete this. Right now we have 0 message, but all the message you want to delete in this message queue, you can delete in one go. But if you want to delete this entire message queue, there's an option called delete. Then this message queue will be deleted. Okay, so there's the option. So technically, almost all the major options we have here about the SQS we have discussed. Very important service in real perspective, or especially for microservices, that is about SQS. So that's all, guys, from my side for today. I believe you guys got this idea, and plus you get some more extra information about further integration part of multiple applications. Any questions, any query, if you have, you can guys ask me. What if message queue server goes down? Technically, Pawan, because this is the managed services, so Amazon has given us some kind of guarantee, right? And they say this service never goes down. They have some 99.99% guarantee it never goes down. And if it goes down, then my front end backend won't able to communicate, obviously. So they have to wait for message queue to come up. Okay, so this is the main thing. So if you see the Amazon AWS SQS SLA agreement, okay, SLA agreement, and here you can see what kind of guarantee they are giving to us about SQS. Okay, so just go and read, and here they say they're giving you whatever guarantee they have, and if you goes down by some reason, right, they will give you as some amount back as a credit and something like this. Okay, so they have entire detail about they're talking about if something goes down. Okay. Yeah, guys, in the message queue, there's one more concept called FIFO. Same concept, nothing is special here. But right now, the way I create SQS, SQS, it is standard. So technically, message would be go in any of the order. Okay, just it's like this. A lot of customers keep on sending the message. So maybe I order right now, my message go, the other message go. So they would be in any order, and they can be processed in any order. And most of the use case, this is a very common scenario. So if my order and their order will be processed in any order, that doesn't matter. But in some use case, I want message to be or processed in the order way. So it's called FIFO, first in, first out. Okay, so what a message go first in the queue, they will process first by the consumer. Till the time my first order is been downloaded by the first customer, the second message won't be able to download by some of the other consumers. So there's the only difference. Otherwise, everything is exactly exactly the same here, almost, right? The only thing is when we create the message queue here, you have to give extension.FIFO. It is compulsory. So your message queue name would be anything, but extension will be FIFO. Otherwise, it won't create. That is a big main difference here about the ordering. Yes, Sunil, OTP also have a similar architecture, because when you send SMS, OTP, everybody is independent services, and everybody get the message mainly from the message queue. Why can't we create multi OS for A and B's under load balancer rather than creating message? Actually, Prajwal, message queue duty is not at all related to load balancer, right? Message queue is just to uh, uh, put your messages information in some centralized location. That is the only difference, right? There's no link of load balancer with this. If the message queue service goes down, Rohit asked me that how communication of information will be done. And that's what, guys, Rohit, they are talking about. Whenever create a message queue server, it's very critical unit actually for us. So we normally create a cluster of message queue server, sometime at a geographic level. So normally it never goes down, but if it goes down, obviously nobody uh, can able to communicate. But it is also based upon your further programming logic. Also, maybe developer might try some code. If message server is not reachable for some time, let's start communicating directly, or let's contact to further message queue server, or maybe have some kind of backup message queue server, or on-premise message queue. So it's purely based upon the programming, what they write for the code. But typically, the way we normally create the message queue is very different. Is always up. Does visual concept come only into picture only when the consumer has poll? Yes, sir, Rahul. As soon as one of the consumer poll the message, your message become invisible for 30 seconds by default. So visibility concept only come when one of the customer or sorry, consumer poll the message. Okay. Yes, Saswant asked me if backend has four machine which are running. If messages come in the queue, then if messages come after 30 seconds, every machine. No, actually, this Saswant, this is per message. So this visibility time is per message. For example, in 1 second, or let's say 1 minute, 1,000 messages come. So let's say message number one used by one of your consumer or one of the backend system, that message only is invisible. That's what I want actually, right? But other message is visible, right? Other consumer can work on other messages. Okay. So this visibility is not per queue, it is per message. So 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 Mohammed, I think I right now very quickly explain you FIFO, pretty straightforward. Is just the way to to order the things. If you something is upon use case to use case, sometime I want I want my message always processed in order. There might be some kind of use case, right? If you don't process in order, maybe it won't properly work. So FIFO would be use case for this. Yes, SQS or Rohit is very much important uh, service in the microservice world. Even though SQS is a product of AWS, but I can say message queue is very important service in the microservice world. Almost any of the microservice world, without having the SQ, without having the message queue, they won't properly configure. What is PERS? I think Ravi, I already told you what is PERS here. Jenkins, normally Resub is not come into the middleware world. You can say it's a very common term actually, middleware. Jenkins is just one kind of helping tool, or one kind of CI/CD tool that is helping you to, you know, integrate multiple tool together. so that they can work for us, right? So maybe sometime we can say Jenkins is a middleware too, but I don't properly consider Jenkins as a middleware. But yeah, message queue is normally a middleware. Okay, or sometimes some of the component of app server, like WebSphere or WebLogic or JBoss, these kind of tools also come normally in the middleware world. In the dead queue, also keep on pulling multiple message time. No, actually, Subham, normally the idea of the dead queue, we create some kind of backup kind of storage. We keep the message there. If we don't pull the message in the dead queue. We give this dead queue to some my developers and say and ask them just go and look why this message have a loop, what kind of loop we stuck, right? And they manually go or some other way they go and try to troubleshoot, right? So polling is always done by consumer, and normally we don't attach some consumer to our dead queue. Okay, normally. After receiving the message in the yes, Subhasari, after receiving the message in DLQ, message still is exist in your main queue, but they won't process. If you see, guys, if you start again polling, they won't process. After they go into DLQ, uh, the loop of again polling the message in your main queue, they stop. If you see there, they stop when I was showing you this example, right? So yes, this service also there, Mayank, in Azure also, because message queue is very common and very important service. In all the cloud, you will find this. To whom I connect to OpenShift training detail, Deepak, you can connect to some of the ambassadors or the our team members or your group head. They will help you with the OpenShift training details. What is the reason behind the fastness of MQ over database? Actually, Pawan, in simple line, if anything is faster, it means they have very limited features. If you keep on adding feature and feature and feature, they become slower and slower. So database has a lot of features. Message queue have no feature. Just keep on storing data. That's all. Okay, that's the only thing, right? So obviously it becomes slow. Plus, there's some kind of programming logic also, and plus the way they store the data is called data structure. Okay, so that also matter. So everything is we have put in the message queue in the best form. Let's make the message queue super fast. So that's all, guys. I'll try to touch as much as query I can see here properly. Otherwise, we have one more class, I believe, on it where I will talk a little bit more about message queue and SNS and some more interesting use case we gonna see here. Okay, so that's all, guys, for today. And see you guys in the next class. Bye. Take care.